Okay. Is it recording? Yeah. Okay, sweet. So, yes, great. Let me move this out of the way. So thank you to everybody who's come to this one. 6 p.m. on a Monday, I really appreciate it, but hopefully it will be of use to you and you'll learn something from it. So as I said to some of you before we started this workshop officially, this is just basically the second installment of DSC and WISE's collaboration workshop series, Python Basics 101, where we're just going to be running through the basics of Python as if you've never seen programming language before. The first installment was a couple of weeks ago. There was an interruption because of Google hash code that happened last Thursday, which is why this is happening on a Monday. If anything like that happens in the future, we'll be sure to let you know through the social medias, so make sure you're following DSC UOB on Instagram at DSC Bham, and also WISE, WISE at UOB. I think it is on Twitter as well. So just check out the socials because you'll see all the information there. Okay, so today we're just going to be running through some more advanced topics from last week, or from the last workshop, and I think I'll just start off with an introduction. I think that makes the most sense. So so I'm Rob. You may or may not know me. I'm a second-year computer science student at the university. I'm studying a bachelor's in computer science, and I am also leading DSC this year, and you might also see me around as socials rep in the Computer Science Society.
Yeah. No, and I'm going to be helping Rob today with the workshop. So I'm Jack. I'm also doing computer science at UOB, and I'm a DSC event volunteer. So yeah. So the contents for today, as Rob briefly said before we started, we're doing a quick recap on variables. We'll do some string formatting. We'll also cover functions, lists, for and while loops. We'll apply what we've learned in like a simple program, and then we'll also, if we've got time, we'll cover dictionaries as well. So
yeah, awesome. So start off with, as Jack said, we're going to be doing some variables and some string formatting, but not so fast. Before we get into string formatting, we really need to take a quick look at variables again to do a quick recap. This won't be as deep as it was last workshop, but we want to look at some interesting properties that will be really important for the rest of the workshop. So pay attention. Okay, so what exactly is a variable? Well, basically what a variable is it's a reserved memory location to store values. And you identify this memory location with names. And hopefully this will work. If I can do a quick demonstration, I'm going to switch over to Python interpreter. Now, last workshop, I think we used Replit or something like that. Feel free to use python.robhallam.uk if that doesn't work, because I know some people said it was a little bit of effort to sign up. This is just an interpreter I've written before that should be quite easy to use if you've never used something like this before. And if you have problems with Replit, you can just use this, and hopefully it will just work. So if someone could drop that in the chat, if possible. But it's just python.robhallam.uk, and you can see it up the top. Is share screen working still? Can you see this? Okay.
Yes.
Let me know. Okay, sweet. Thank you. Okay, so as I said, basically, you can identify a variable with a name. So we're going to call it name here. And for example, going with me, I'll just say the value is Robert. And to see the value of that variable, we can print it. So this is just something you should be sort of familiar with because we did it last workshop, where basically, as I said, name is the variable identifier, and Robert, which is a string, which is just a sequence of characters. This is the string. It is the value stored at that memory location, identified by name. This here is called defining a variable, and it can happen at any point in the program. And a nice analogy I like, which is slightly spoiled by this thing here, but is the box. Okay, so if you imagine a box, the content, i.e. everything that's stored inside the box, is the variable's value. So Robert in the example I just showed you, or hello here in this picture. And it's the label, so the message here, or name, is the variable identifier, and it's what you use to know where to find the value stored inside the variable. It's what you pass to the program to get that value. So like print name, for example, or print message. Now, it's so useful because you can get that value anywhere in the program, really. So
one thing that you need to be familiar with when using variables is scope. So each variable will have its own scope, and that refers to the visibility of that variable to other parts of the program. So when we come to functions shortly, they're a great example of it, because when you define a variable inside of a function, you can't use that variable outside of the function because its scope is isolated to that function. So, and also you can't use variables that haven't been defined yet, because going back to the box analogy, that would be like trying to get contents out of a box that just doesn't exist. So that wouldn't make sense. And also because programs sort of follow a timeline, so they go from the first line to the last line of the program, you can't use a variable before or earlier in the program than when you define it. So you've got to define a variable before you can use it. Okay, so we're going to cover some formatting strings now then. Yeah, and so say if we want to welcome a user to our program, but we don't know what their name is yet when writing, when writing the welcome message. So if we want to say hello username, welcome to my cool Python program, but we don't know the value of the usernet, we can solve this using formatted string. Now there are multiple ways to do this in Python, but the way that we're going to show is by using the formats at the end of the string. This method was added in Python 3. So
yeah, I can do a quick demonstration of that if you want to see it. So basically, let's say we have a variable. Oh, I don't know what's doing that. Let's say we have a variable called username. Let's just say some cool username like cool dog123. I don't know. First thing that comes to mind. Okay, so and then the message, like Jack said, let's say it's just a welcome message, and we say hello, the name. So I'm actually going to leave this blank, like it's just not there for now, and we'll fill it in a second. And I'll say hello. We want to say cool dog123. Welcome to my cool Python program. How exactly do we then fill it in? Well, there are, as Jack said, there are a few ways of doing it. A cool way that you can look at after this workshop is using F strings, which are really nice. I might be able to do a demo here, but I can't promise it works because I haven't tested it. But what we can use in this example is dot format. So the way that works is you just write this string, again, a sequence of characters, then call dot format on the end and pass it the variable. So in this case, it's just variable's username. And how do we know where to put the variable, the string, which is pointed to by username, which is just called dog123? How do we know where we want it? Well, using curly braces, and we place it in the location where we want it. So in this case, it should be here. Hello, cool dog123. And hopefully, if I haven't messed this up, by printing message, it should print hello, cool dog123. Welcome to my cool Python program, which, as you can see over here in the console output, is exactly what it does. But let's say we had more than one variable that we wanted to put into the string. How do we do that? Well, there is one way of doing it. Let's say instead of saying cool, we just wanted a general adjective. You could just have another curly brace and then put in adjective here. And it knows that username will go in the first one and adjective will go in the second one. That's just how it works. And we can fill in adjective, let's say, with awesome here. And run that. Whoop, we don't want to save that. Run that. And it fills it in with welcome to my awesome Python program. But the question you might be asking now is, just for some more security, I guess, how would you do it so that you don't have to worry about the order here? Because at the moment, the order matters. If we switch these around, it's going to change the order that appears in the string. And that's really critical because we don't want to, this sentence doesn't make as much sense as it did before. So how can we do that? How can we change it? Well, there is one way of doing this, and that is just in between the curly braces, we can give the curly braces basically variable identifiers, their own little identifiers. So let's say we call this username string and this one adjective string. And then despite the wrong order in this format over here, again, this is just objectively wrong. Technically it's right because it's compiling and it's working and it's running, but it doesn't make sense when we're reading in English. So I can instead write adjective string equals the variable adjective, and username string equals the variable username. And what that will do is it will say, okay, the value of username, which is called dog123, will be placed in here, and the adjective string will be placed in here. And by running that, our formatted string is fixed despite the wrong order. So yeah. That's a quick demonstration of formatting strings. Now you know how to define and use variables in Python, which is really a fundamental concept of any programming language. It is really fundamental, as well as you can now apply them to the cool and extremely useful technique of string formatting. So yeah, over to Jack now, I think, about functions.
Okay, yeah, we'll talk about functions. So, well, what is a function? I mean, you hear a lot of people calling functions all sorts of names like methods, subroutines, procedures, and While there are differences between them, they're ultimately talking about the same thing. So it's a block of code that only runs when it's called, or more precisely defined as a block of organized reusable code that is used to perform a single related action. So an example which you've actually already seen is the print function. It takes one argument, and this is the word used to describe as an input variable. So what it takes as an argument is the string to print, and then behind the scenes, it handles all the processing need to actually output that string into the console. So why would you want to use functions, really? Well, I mean, the biggest advantage of it is code reusability and code readability. So
if I do a quick demo here while you're talking, Jack.
Yeah, so no, say you wanted to run a calculation such as adding 3 numbers multiple times, like X, Y, and Z, for instance. You wouldn't want to actually write that calculation 3 times like Rob's doing now, because that would just be excessive. I mean, so what you do is you define a function to do that.
And that's what I can go ahead and do here. So yeah, like as Jack said,
define a function now, yeah.
So yeah, as Jack said, if we want to do a different calculation 3 times for 3 different variables, we'd have to redefine 3 different variables 3 times and then run this 3 times. But it's the same calculation, so we can, it would just be redundant if it's repeated. So yeah, we can use functions to do that. And how exactly do we do that? Well, basically, functions in Python are defined using the def keyword, basically short for define, I think. That makes sense, doesn't it? And the name of the function comes straight after. We can call it whatever we want. I suppose the most logical name for this function would just be sum of 3, and then ABC, because we're summing 3 variables or 3 values. And then we can do the calculations inside. So ABC here are essentially arguments. It's like Jack said with print name, the name is the argument. It's kind of like if you look at an analogy of sort of in a kitchen, you have the ingredients, they're basically the arguments, and now you need to write the recipe inside the function. And this recipe is really what kind of create, it's going to create the output that you want, because at the end of the day, you just want the sum, you want the value. It's like just like you want the cake. You have all the ingredients, now we're writing the recipe, at the end we'll get the cake. Okay, so number sum, if we do sum A plus B plus C here, which is the recipe, and then let's say we just want to sum, we just want to print it because that's what we did before. Now, if I ran this, nothing's going to happen, nothing's outputting, because basically we've written the function, we've given the values, but we haven't called anything. We haven't called the function, we haven't told the function to run. So to do that, you literally just write the same name you define the function with, and you pass it some real values. So we're going to pass it X, Y, Z, because they're already defined. It can be variables or direct values. So first, we just pass X, Y, Z. Now, that will output 9, simply because X is 2, Y is 6, and Z is 1. It's then passing these values, these actual values, into this function, summing them, and then printing them. So obviously 2 plus 6 plus 1 is 9, which is where 9 is outputted. As I said, you don't have to pass variables. You can pass direct values. So let's say you pass 10, 5, 10, 20, and then ran that. That would be 35, just like that. But another key thing about functions is you must declare a function before you call it. So if I switch this around and I copied this call of the function up here, where I'm calling the function before it's defined, and I run it again, it's going to throw an error, a name error, saying name sum of 3 is not defined on line 5 in main.py. This is main.py, you can see up here. And on line 5, you can see we're trying to call this function, but it's like a timeline, basically. That is what variable scope is about. Remember variable scope. This is why it was so important. This is why I said to remember it, because it basically applies to functions the same way. If we read it as a timeline going down, these numbers, so 10 is later and 1 is earlier. It's not exactly like that, but you can see it like that and interpret it like that. Basically, we're trying to call sum of 3 before it's been defined. So it doesn't exist yet. It's not aware of its existence, essentially. So that's what the problem is. And if we obviously put this back underneath, it will work just as intended with no errors. Sweet. So yes, I mean, the next thing, I guess, is let's say you don't want to print the result, but you want to return the data as some sort of value, maybe because you want to process it. I imagine, especially if you've got an assignment, say you're doing physics and you've got an assignment, you're going to have lots of data you need to process, and you might be getting that data from functions or taking data from maybe a database and passing that into a function that then returns the data back, having processed it somehow, some way. how exactly do functions pass that data back? Well, they're written using the return keyword. And I can change this function, same function here actually, and just put in return, and then the value we want to return. So I think the value we want to return here is, I mean, we could just use this, stick with it, and just say number sum. Now, if I run this, I think it might throw an error. Well, it doesn't actually, it doesn't do anything, but you can see the print's gone off. It's disappeared in the console on the right, in the command terminal. There's nothing there because we've returned it using the return keyword. But we've returned it and we've basically just tossed it in the air and like thrown it away. We're not doing anything with it. Before print was handling it and it was printing it to the screen, but now we're not doing anything with it. So how do we get that value that we're returning from the function and actually do something with it? Well, we can use that by just assigning it to some variable. So let's say result is just a name. And I'll just replace this variable with this one so you can see it here, this function. So we want to get the value from sum of 3, which we understand is 35. It's 5 plus 10 plus 20. And we want to take this value. This is going to jump up to here, do the calculation, 5 plus 10 plus 20, return it, and then pass it back to the value in result. And result is going to store the value, the variable. And so if I run this now, nothing will happen again because we haven't printed it. So I'm going to do that right now, print result, and you can see 35. Sweet. So everything's working as intended. And you can see that we've taken the value from sum of 3, stored it in result, and printed it. So yeah, I think, Jack, do you want to go ahead and talk about some lists and loops now, I guess?
So lists in Python, they're data structures, which is just a way of storing data. So they used to store multiple items in a single variable. And Python has 4 built-in data types to handle storing collections of data. These are tuples, sets, dictionaries, and lists. So, and I mean, we'll cover dictionaries briefly at the end. So why would you want to learn lists anyway? And I mean, there's loads of real world applications of why you'd want to use lists. So for example, on the next slide, there's, what could we switch slides? Yeah, cheers. So yeah, so I mean, maybe you want to have a list of all the students in UOB, or have a diagnosis of many different patients, or weather throughout the year, stock prices over a certain period. But there's loads of applications why you'd want to use them. So lists are ordered, changeable, and allow duplicate values. So what does this mean? When we say that ordered means that lists follow an order, so the items in it have a defined order. And if you add new items to it, those items get placed to the end of it. The changeable means that we can add, remove, and change different values in the lists, and also allow duplicates, as you can imagine, means that we can have multiple of the same item in lists, but that have different indexes. So that have different positions in the list.
Exactly. So yeah, so I'll go ahead and do a demonstration now of lists so you can actually see how they're used. I guess it makes sense to put it in here. So yeah, as Jack said, you can have duplicate values inside the list. They're just distinguished, they're separated by their indexes. So if you're placed at the start or at the end, it knows the difference between an apple and an apple because one's at the start and one's at the end. That's how it knows the difference. So let's first declare a list. How do we do this in Python? I showed you briefly here on the slide. I'll write it here again. They're basically defined using square brackets. And then the elements inside can be anything really, but we'll start off with a list of strings. So let's say apple, banana, and cherry. Did I spot that right? Now if I run this, I've declared the data structure, but I've not done anything with it. So we can just go ahead and print it just to see it, and it will print it exactly as we declared it here. It's simplified the quotations to single quotations. Doesn't really matter. It makes sense to us still. Okay, so what we can also do is it doesn't have to be strings. Currently these are strings because they're sequences of characters, but we can change this up, and let's say instead of apple, we could have just a number, an integer, 6. And instead of cherry, we could have a boolean, which is just true or false. So if we have true, we print that, it's fine. Python's fine with it. We can have as many data types as we want in one list, and Python will handle that just fine. Yeah, as Jack said about lists being ordered, the way they're ordered is that items in a list, elements in a list, like 6, banana, or true, are indexed. they're basically just given a position, a value associated with them. That's what I mean by indexed. Now, 6 here will have index position 0, banana will have index position 1, and true will have index position 2. And the reason for that is computers count from 0, unlike humans, or as you would naturally, unless your favorite way to count is from 0, I don't know, but wouldn't judge you, but I think most people count from 1 upwards. Meanwhile, it's very worth knowing that computers count from 0. So 6 here will have an index of 0. So I'm going to change this really quickly to apple, banana, cherry again, just to keep it consistent. And what we can do is we can print to get the value. So let's say in the instance of you have the index, but you don't know what the value is. How do you get the value at that index? Let's say we want to grab the first record in the student database. We want to get the name of the first student. We don't know the name of the first student. We want to get that. We can just say, let's get the name of the first student, which is index 0. In this case, it's a fruit list. And if we print that, oh, what have I done? Sorry about that, syntax. If I run that, it will say apple. It's going to return apple because apple's the first element. Similarly, if I do this again with 1, it's going to take banana, which is the second one. And another cool thing you can do in Python is you can count backwards, you can count reverse in a list, which not many people know, but it's very useful to do. It's very useful in for loops, which we'll get into in a little bit. So you can use -1, and that will take the last element. And as you would expect, -2 should take the second to last. So if you think about it, cherry's the last, banana's the second to last. So we should get cherry banana, which is exactly what we get. Sweet. So also another thing Jax mentioned was that lists are changeable. How do we do that? Well, okay, we can add and remove elements. How do we add? Let's first add. So I don't know, let's add an orange. How do we do that to this list? Just using append. In Python, it's append. In different languages, it's different things, but ultimately, it's the same operation. You're just appending an element to the end of the list. So if we're appending orange, we're just going to pass the argument. This is a method. Don't worry about the differences between methods and functions. It's kind of like a function. In the words of it's taking an argument and doing something with it. It's not quite returning it, but it's doing something to the list. So by running that, I'm not going to do anything, so I can't see the fruit list. But if I print fruit list, we can see we've added it to the end. And let's say we want to remove a value as well. I'll do it before the print so we can see it here. Remove fruit list dot remove. This is easier because append is a little bit weird because you wouldn't normally maybe use the word append in a sentence. But remove is pretty easy to remember, I think. Remove, let's say, banana. And that should remove banana and add orange, hopefully. Running that. You see banana's gone, orange is added, and also going back to the properties, as Jack said, the order remains the same. Apples before cherry, cherries before orange. Banana isn't there anymore, so we don't worry about that. So yeah, I think Jack, do you want to go into for loops now? Are we going to go? Oh, no, I think I'll start with for loops. So yeah, okay, I just want to go over to this slide here, because I want to flex the memes. So for and while loops. Here's a nice old meme that hopefully, if this is your first time doing for loops, you remember this. It'll make sense if it doesn't already in a little bit. So for loops, what exactly we do? What are they? Well, okay, so for loop, which is the first of the loops that we're going to look at, is used for iterating over a sequence, a list in our case. And with the for loop, we can execute a set of statements or program lines, basically, one for each item in the list. Now, the basic syntax is just like this. So let's actually get that fruit list back. I'm just going to copy one over here, I think, just to speed it up. I want a longer one, because this is the great thing about fruit list, or not fruit list. It's a great thing about for loops. It's a great thing about for loops, the fact that you can do operations to long data structures. Because if you remember, when I was trying to print all those elements, it was a lot of lines and it was a lot of effort. And you're probably thinking like, can you just type this faster? Well, that was like, so let's say in this case, we have seven elements. To print them all, you have 7 lines of code, 7 print statements. We can actually do that in 2 lines of code with a for loop. And the way that works is just having for x in fruit list, print x. If I run that, you can see, sweet, prints all the elements. So how does that work? Makes no sense if I'm just running it and not explaining it. So if I dissect this now, what is happening here in this for loop is x is basically a variable, but unlike the variables you've seen before, where we define it explicitly, it's created by the for loop here, essentially. Now, x is a temporary variable too, and it takes the value of each item in the list, each fruit in our case, with our fruit list, starting from the first element and ending with the last. Now, each loop or iteration is also going to execute a block of code inside the for loop. It's a block because it can be several lines of code. It doesn't have to be one. It's one line in here, but it can be several. And basically, so what it's doing is it's taking the value of the first element in this list, printing it, then taking the value of the second element in this list, printing it, and doing that for all elements really quickly. 2 lines of code, bam, we've printed all of them. But one last thing, I think we want to remember variable scope. If I try and print x outside of this for loop, it's working. That wasn't expected. I think if I try, I think a better analogy of this is if I write y equals 5, and then let's say, if I write y equals hello, and I write hello, I'm just thinking on the dot here, and I print that, it's going to append it to everything here. But if I print y here, I don't know why that's doing that. 4x.
The reason, just to interrupt here slightly, the reason that doesn't, the reason that continues to work is because for loops and if statements and all of those don't actually introduce a new scope. Only functions introduce new scopes.
Thank you, Justin. Okay, yeah. I'm in Java land over here, getting confused with variable scopes, as far as I'm aware. So yeah, that's a very good lesson for all of us. I think variables in for loops. They don't have their own, as you can see here. A bit of testing, that's all that, it's a good lesson, to be honest. If you test, you'll find out, it's the best way is just to get your hands on the code, in my opinion. So you can see, just by printing y here, we found that we can actually access it outside. If I printed this and it threw an error saying can't see it, you'd learn that the variable scope doesn't apply. But yeah, we've tested here and variable scope does actually apply. Okay, so now I think we're, Jack, you want to mention something about for loops?
Yeah, so now if you, so sometimes you might want to have a bit more control over the loop, and you might want to perform certain actions on certain elements, or you might want to stop the for loop completely. So yeah, there are ways to handle that, and Rob will type it out now. So for instance, if you didn't want to print the element cherry in the fruit list, like you'd use the word continue. And the word continue just goes to the next iteration of the for loop, and it doesn't execute any code after that line in the for loop. It just goes straight on to the next one. And then there's also the keyword break, which just breaks out of the for loop completely. It stops that iteration there, and it stops any further iterations of that for loop, and it just gets out of the for loop and continues the code after that. So in the code that Rob's done, it won't print cherry because it continues over it. And then also it won't print mango because it breaks out, and it won't print watermelon or strawberry. So yeah, that's as we imagined.
So yeah. Hopefully that makes sense. Reiterate it maybe. As Jack said, apple, banana printed as normal. Continue skips over but remains inside the loop. And that's why we can't see cherry, but it continues on, prints orange, and then mango completely exits from the loop. So yeah. Sweet. Okay, so
yeah.
I think one last thing I want to mention about for loops actually is a range function. This is so I think, for example, if you want to iterate only a set number of times, and you know exactly how many times you want to iterate, right, rather than across the whole data structure. In this case, if you only want to iterate over the first 5 elements, for example, we can use the range function. And what the range function basically does, it's a function that when called returns a list, essentially like an iterable list, in some sense behind the scenes. You don't have to worry about that, but basically it allows us to iterate this many times. So it's going to produce a list with 5 elements. So we're going to basically iterate 5 times. And in this case, X is going to take that value. It's going to take the value in the list, each value in the list, just like it did here. But in this case, it's just a list of numbers, basically, sort of behind the scenes. You can think of it like that. So if I print X here, what you might think is it's going to print from 1, 2, 3, 4, 5. But if you remember, computers count from 0, so it's just going to print 0, 1, 2, 3, 4. So it's still 5 numbers, but in our case, it's only printing from 0. And you can do something with this X, just like you would in another case. So let's say using format, just like this, let's say X, this way we can say X equals something. If I remove this actually, X equals something, and then X times 2 equals something else. And this is also evidence that you can do a calculation in format. So in format, we'll say X is the first value here, and then X multiplied by 2. You do the multiplication with an asterisk in Python, and by 2. And we're going to pass this value, X multiplied by 2, into this second variable. By running that, we should get X equals 0, X times 2 equals 0, and then everything else as expected, if you take a glance at that. So yeah, that's just about range. And I think now we're going to go on to while loops, which is the second of the loops that we'll be covering today. So yeah.
While loops. So, I mean, sometimes instead of using a for loop, sometimes you'll want to iterate. You don't want to iterate a set number of times. You'll just want to, or you don't know how many times you need to iterate. So that's when you'd use while loops, and you could just keep iterating until a certain condition is met. So this is when you'd use while loops. And we'll demonstrate a simple while loop here, in which the condition will be I is less than 6. And you'd print I if the condition's true, then you just increment I and it'll keep going until I is no longer greater than 6.
Yep. So the condition here, it only executes this block of code, just like for loops have blocks of code, only iterates this if this condition is true. So if I run that, it will print all numbers 0 to 5, just like Jack was saying. And Jack, do you want to also mention else statements? Actually,
you can also add statements to it. Similar to if statements, you can have an else statement. So if the condition isn't true, then it will execute the else statement, and that only happens once, and that would just say at the end, I is no longer less than 6. So yeah, you got to be very careful. Oh, sorry, it's not my part anyway. So.
That's fine. I think yeah. So the one thing to watch out for with while loops is that the condition here should really be broken at some point. Here we know it's going to be broken because this little thing here, actually I glossed over briefly, it's just a shorthand term. It's basically doing this, I equals I plus 1, it's the same thing. It's just a shorthand quick term of doing that, so I thought I'd just show you that as well. It's just it's an increment basically, and you can also do it with I equals minus 1. And this should be an example of an infinite loop as well, I think. Yeah, so you can see it goes on infinitely. And the reason this is going on infinitely, and it will literally go on infinitely if we had infinite amount of time and infinite amount of sort of memory space and computing power, etc., is because we're saying loop this code if I is less than 6. Well, if we're constantly decreasing, it's never going to go above 6. It's going to keep going down to negative infinity, or whatever number you want to call it, negative a million. It's going to keep going down that way, and it's always going to be true. So that's one thing you need to watch out for. If you have an infinite loop, it might be because the condition is never being broken. Yeah. So yeah, I think as with variable scope, let's try and print I. If I remove this I, actually, let me try something. Well, actually, if I just add another variable like I did before, I think the variable scope should still be accessible anywhere in the program. So if I do y equals hello, I'm not going to do anything with it. I'm just going to print it outside because that way it's inside the while loop, and then I print y, and I'll change this as well so it doesn't go infinitely. And we can see. As we all learned before, variables inside of while loop and variables inside of for loop have global scope in Python. So you can see y is declared inside while loop, but it's not. You can access it outside of it. So yeah. I think now what we're going to do is do a little quick program applying what we've learned. Now you can program along with this, you can write the code along with this if you want. I know we've got about 20 minutes left, so we're going to try and fit it in there and then do a touch on dictionaries at the end. But what we're going to try and do is, this is actually based on the application you wrote last workshop if you were there. Don't worry if you're not, because we're going to be writing it quite quickly from scratch. But the idea is we want to write a a program that will have a user interface, a nice user interface. It will ask the user, do they want to draw a shape? And it will say, for example, enter 1 to draw a triangle, enter 2 to draw a square, enter 3 to draw a circle, and it will also give the option to quit, because it will draw the shape and then it will keep asking until the user quits the program. Just like in a game loop, if you're playing a game, it keeps executing the game code until you quit, until you turn off the console. So it's kind of the same. So that's our goal. We want to have a nice little interface that allows us to draw multiple shapes and create little patterns and create cool patterns. So I'm going to start off with over in the Python interpreter and write it all in here. All of this code will be made accessible to you at the end in a little GitHub link. So I'll send the link later. But you can code along if you want, but don't worry if it's a bit too fast. Just try and listen, and hopefully it should be quite intuitive. So step 1, as we did last week or last workshop, we're using Turtle to draw shapes, which is just a library. A library is just essentially a collection of functions, so don't worry about that. How do we get those functions? We have to import it. So we're going to import Turtle, and we're going to create the Turtle. You can just get this from the documentation to create the Turtle. Running this won't do anything yet, but it will create the little Python. It will create the little Turtle window here, which we're not drawing anything. We're not doing anything with it yet. So first, we want to give the user some options and say, hey, what do you want to do? So this is a little thing you may or may not have seen before, but it's most ways where you print things, you're probably printing one line, like hello world or something. And to do that, you use double quotation marks and it just prints this. But what if you split this? So say you had like a long essay or paragraph, and you ran this, it's gonna throw an error. So how do you do multi-line prints in Python? It's actually quite easy. You just do 3 quotation marks. Start with 3 quotation marks instead of double quotation marks. So that's 3 single quotation marks, just like this. And running this now, if I remove this double quotation here, separates them onto multi-line. So you could have a long paragraph with triple quotations here, which I think is pretty cool. So we're going to make use of that actually. And what we're going to do is we're going to write a little menu that just says, choose any of the 3 following shapes to draw. And then we're going to give them an option maybe of a square, a triangle, and a circle. And we're going to ask them they can also quit the program if they enter 4. Now, we can write a little thing at the end as well, I guess, to say, if you enter none of the above, well, we can draw like a line, for example, let's say. And the reason just for doing that is that it will allow us to make use of else statements, things like that, to capture every other instance. So if they enter 5, 6, 7, banana, it will draw a line, hopefully. Okay, so the next thing we want to do after we've written a little menu, and we can test that by running that. It's cool. So we get the prompt. We can't do anything with it yet. So if you remember from last workshop as well, we can take the input and assign it to a variable we're going to call choice. So we're going to convert it to an integer because we're expecting an integer 1, 2, 3, or 4. And so we're going to convert it to an integer with int. It will be taken in as a string from the user, but it will be converted to an integer with this int, this int encapsulation of input. And we're going to write a little prompt that says, sorry, not Python, pick your choice, and then just say enter number 1 to 4, I think. And then a little thing there, and hopefully that will work. And now we're going to take it in. Oh, what did I do wrong? One sec.
Missed an equals.
Missed an equals. Oh, my bad. Sorry. Thank you. I was looking at the right. I didn't check out the left. Sweet. Thank you. Yeah. Awesome. So that will now take an input. If we enter a number, nothing's going to happen because we're not processing it. So let's process it. Let's do something with it. So let's write some if statements, I think. Again, this is mostly using the stuff from last workshop, just if statements, taking user input, printing, so it's relatively steady, okay, but we're about to get into the stuff we looked at this week. So actually, I think, yeah, let's write the if statements first and say if choice, I'm going to put it in bracket, if choice is 1, remember the double equals is a comparative operator, it's saying is equal to, so if choice is equal to 1, and we want to do something. What do we want to do? We want to draw a square. So for now, I'm just going to say print draw square so that we can run this and check the if statements are working. A second option is, let's say, choice equals 2. Print draw, what do we say, triangle. And elif choice equals 3, you want to print a draw circle, otherwise else. They're just multiple options, and in the other case we want to draw a line. And the reason you might notice that I'm leaving out 4, the option 4 here, is because the quit program isn't exactly like, it's not exactly something we're going to do straight on, and it's not something we're going to do with a single command. We're going to implement it in a little bit of a smarter way in a little bit. So we're just going to leave the first 3 options there and test that that works, and run that, and hopefully this will work. So let's say we enter 2. It says draw triangle, so that would hopefully draw a triangle eventually. We run this again and say draw type 17, draw line. What happens if I type banana? Will it throw an error? Will it just say, yeah, we'll throw an error because it's trying to convert a string to an integer. That's basically what that's doing. You can catch that with multiple other things. You could, for example, check that it's an integer using some if statements or using some other methods. You can have a Google about that. That's what most programmers do, to be honest. In this case, you might be like, how do I check that an input is a string, is an integer and not a string? And in this case, it might be really simple. I'm just focusing on what we need to do next. But in some more complex situations, you can just have Google and go on Stack Overflow or something. So in this case, we're going to pretend that we're only allowing the user to enter integers, and that they're only going to enter integers. So if we do enter like 1,000,000, it will say draw line. Sweet, okay, that works. So the next thing I think we're going to want to do is now implement this quit program feature. How are we going to do that? Using while loops. And the reason I want to use a while loop here is because I want to say the condition, they should be asked over and over again to enter a number to draw something until they enter 4. So the condition, we want to iterate while it's 4, while it's not 4, sorry. So while the choice isn't 4, we want to do all of this. And remember, indentation in Python is critical. So I'm just going to tab this by highlighting all and pressing tab to shift it into the while loop. And then at the end, we need to ask for the user to input again to actually check that they're going to keep asking. So, otherwise, actually, if I test this, we can get into an infinite loop by entering number. Can we? I suppose. No, we can't really. No, actually, it will work. Yeah, you'll get into an infinite loop, because if we type 3, we're going to pass the value here, which is 3, into this while loop. It's not 4. That's good. Let's run in here. 3. Okay. Let's print draw circle. Iterate again. Still not 4. It's 3. Let's draw circle, and it will keep doing that infinitely. Nothing's ever breaking. It's always true. So to stop that, let's take the input again. And by taking the input again, I'm just going to copy it actually from up here. We can stop that from happening because it will get halted when it asks the user for an input. And if I do 3 here, it will say draw circle. Hopefully eventually it will actually draw circle. And then it will stop and ask for an input again. Here, here, here. Until finally we enter 4 and it stops the program because it's taking 4 from here, going back into the while loop condition, seeing that choice is indeed 4 now, and so breaking, and it's going to the line after this, so line 27, and it's going to go basically to line 28 where there's nothing, and it's going to stop the program. It's going to stop completely. So that's what's happened there. Okay, so now I think what we want to do is actually draw something. So we're coming to the end here, and we want to draw some shapes. So what I can do is I can draw, well, actually we can fill in the circle really quickly. Because the circle's one line in total. We can just draw t.circle and then like a radius, I think that is, so 50. And same with a line, else we can do t.forward 100, and that will move 100 pixels or whatever forward in a straight line. So they're done. Hopefully that will work. So if I ask for 3, draw a nice circle for us. And if I enter something else, wait, let me stop that. If I enter something else, go draw a line. Sweet, okay, that works. Now let's draw the square. And what I'm going to do is, if you remember the timeline of the program, we need to make sure that before we call the function, we need to declare it, we need to define it. So I'm going to define the functions at the top, which is what I suggest doing. At least make sure you do it before you call it. So we're going to write it right under t equals turtle.turtle here. And I'm going to define a function and say define draw square. Exactly the same as we did with sum of 3 before. We're going to draw a square here. And if you think about it, The way you draw a square in Turtle is you draw a line, so forward 100, and then you want to turn right 90 degrees, then go forward 100 again, turn right 90 degrees, and do that 4 times, and that will hopefully create a square. Now you could obviously do that 4 times, so just write t dot forward 100 and t dot right 90, and copy and paste that 4 times. But remember, for loops, this is exactly what for loops is supposed to help you with. Reducing code redundancy, basically, and improving code reusability and readability as well, because this is a little bit hectic. It's just like more lines you have to read. So we can use for loops here as well. And if you remember how you iterate a set number of times, is you can just say range. So we can write a for loop, for I in range, 4 times, and then just put these lines of code inside the for loop, and that will hopefully draw our square. So if we insert square here, instead of printing, we just call draw square. Notice here that we're not passing any arguments, so you don't have to. You can pass 0 or more. If we run this now and we enter option 1, draws that square for us. That's perfect. Sweet. And let's do the same thing for triangle. Not spend too much time on it because it's relatively trivial. Once you've done draw square, once you understand that, it's the same logic. Draw 3 times, and in this case, with a triangle, you want to draw forward 100 and draw right 120. This is 360 degrees divided by 3. And then we run that, and now if we have to call it first, don't we? So in here, draw a triangle. Run that we'll draw a triangle. Sweet. So we've got that. Let's try drawing a square. We draw a square on top of that, like a little envelope shape or something like that. And let's say we drew a circle now, draw a circle on that, and then, I don't know, move forward and draw another, I drew a square again. Oh, that doesn't matter. So if I enter 1,000,000, something like that, go forwards, what's the circle? The circle is 3, right? And we draw little ears or something. So you can see like that. So it's a nice little program that works just like that. And there's not much more to add there. We've used for loops, we've used functions, we've used multi-line prints, we've used while loops, if statements, elif statements, else statements. You've taken inputs from the program. It's really used quite a lot, and also libraries as well. So this is a fully fledged Python program. Don't worry if it's overwhelming. If it's not, that's amazing. It means you're learning quite a lot. But if it is, just take your time. You can dissect this line by line. And again, this workshop will be recorded and posted later. So you can check it out and rewatch it if you want to. So yeah, with that said, I think now we can do a quick whistle-stop tour of dictionaries.
Yeah, we can do some dictionaries and then answer some questions if anyone has any.
For sure.
So yeah, dictionaries, they're one of the data structures that we spoke about earlier, and they store collections of data. So what they do is they store key value pairs of data, and similar to lists, they're ordered and they're changeable in the sense they've got an order and you can change the values in it, but they don't allow duplicates. So you can't have a key pair with the same keys. Like you can't have 2. So yeah, you can't have 2 with the same keys sort of thing. It doesn't allow that. And so yeah, and the way the syntax to use it is on the slides there, and you use curly braces to do it, and then you put the key, have a colon, the value, and then you separate all the different key pairs with commas, and that's how you do dictionaries. There's loads of other functions that you can, methods you can use on dictionaries as well, similar to lists, like append and remove and stuff like that as well. But there's a link in the we'll put a link in the chat where it can get all those functions and methods and that.
Yeah, so I can actually share one cool resource is W3 Schools, which I think I can pull up now. It's probably the first thing you find when you Google dictionaries in Python. And I can just enter it here, just like this, and we'll hopefully, wait, can I put it in the chat right now? I'll be able to. Oh, sweet, thank you, appreciate it. So yeah, you can see dictionaries here. It explains in plenty of detail as you read through. Similar thing with what we said here, it's ordered, changeable, does not allow duplicates, as Jack said. You can't have the same key value pair. Just like you can have apple twice in a list, you can't have it in a dictionary. You can have fruit apple twice. And you can see here, you can create and print the dictionary using this and try it for yourself. Dictionary items are cool. This will basically allow you to get the value given the key, which is what Jack was saying. Just like in a real dictionary that you're probably used to, you look up the definition, don't you, with the word. So the key is the word, the definition is the value. You look up the word, you get the value. get the definition. So in this case, we're looking up the word basically, and we're getting the definition, which is forward. The key being brand, value being forward. Key being model, value being Mustang, etc. You have loads of different variables, values in here. And the cool thing about dictionaries is, I mean, I think you can have nested dictionaries as well. And that just means like a value could be a dictionary. And this allows you to create cool things like you can create databases with dictionaries. So you can have student, little name, Robert, age, 19, like date of birth or whatever. And you can put that all in here. And then have a record for every single student and have a different dictionary maybe for every single student. And that way you can look up the name, just like I was saying earlier, using name rather than having to say use index 0, because that doesn't really show up as any value. In this case, you can use name. So actually, if I copy and paste this here, you can use name right here. I'm just going to overwrite this. Let's say instead of brand, we have name. We can get the value name by doing print this dict. Make sure it's case sensitive in Python, remember. Name, and I think that is right. Yeah, and you'll get the value given back, which is Robert. Now, yeah, as I said, you can, and as Jack said as well, you can find some really cool applications of what you've learned today, tying in what you've learned today with dictionaries. So you can use loops and lists with dictionaries to make some really cool applications. And really, the possibilities are endless. And I think also for a lot of courses that maybe you're doing, you can see some applications of dictionaries everywhere as well. Like if you might have data sets given to you in a dictionary or maybe in a list, and you'll have to parse it and you have to handle it. The way you could do that is just have a read through these documentation or this tutorial basically. There's loads out there. Some videos as well if reading isn't your thing, if you'd rather watch a YouTube video and just like listen to someone talk about it. There's plenty of resources like that out there. But yeah, I think that's all for today. Thank you so much for coming, and I think I'll just play this last little slide because it's nice, little light-hearted. Even if you just learned one thing from this workshop, I think you should really be proud of yourself, because starting a new topic or starting a new concept is always daunting. I know for sure. You've really got to push through. So even if you pull just one thing out of this workshop, it hasn't been a waste. And the fact that you made it to the end of the workshop, I think you should give yourself a pat on the back at least. So yeah, no, thank you for coming.
Yeah, thanks. If you have any questions, I mean, you can ask them now, or you can message us if you don't want to ask them in front of anyone. So we're here to help. So thanks a lot for coming in again. Cheers.
Yeah, thank you so much. And I guess about DSC and WISE, DSC, we have obviously the exam week is next week. So good luck to everyone with their exams. And we probably won't be hosting any workshops in that week. But we'll have a chat with WISE about the next workshop and get that out to you as soon as possible. As well as I think we're hoping to run a Gradle workshop for any like tech enthusiasts the week after week 6. So Charlie from DSC core team will be hosting that. And then we'll also have a more advanced Python workshop coming up that Justin, the DSC lead from last year and also core team here, will be hosting later on, hopefully. So that will look into some really cool concepts in Python. But yeah, thank you so much for coming. We'll end the recording now.